So, final talk of this session is Mariane Delaunay talking about whether or not birds have whiskers. Go ahead.
Thank you. Thank you for having me. So do birds have whiskers, and more especially, what is the role of the avian Richter bristles, and do they have the same role than mammalian whiskers? So the sense of touch is one of the most complex and specialized sensory systems, and it comprises detection of stimuli from outside and inside the body, giving a sense of position, of movement of the body, but also stimuli from the environment. And the stimuli are mediated to the brain by tactile sensors present in the skin, and sorry. So mammalian and avian skin have a similar basic structure, and they both possess tactile sensors. So two of them are of interest here. So the Palaeontology corpuscle and the Messner corpuscle in mammals, which are respectively herb corpuscle and cranberry corpuscle in birds. So their pattern distribution and their number vary among the species, and notably with feeding behavior. So herb corpuscle are lamellar nerve receptors that are really highly sensitive to pressure and vibration, while cranberry corpuscle are sensitive to velocity. Whiskers are tactile hair present in many species of mammals, of which rodents like rats and mice, insectivores like shrews, or pinniped like seals and walruses are the specialists. They actively employ the whiskers as they have highly mobile organ that is thanks to the number of muscle bundle all around the follicles, as you can see here. And they also have numerous tactile sensors all around those follicles that help them discriminate substrate. So mammals are capable of moving their whiskers back and forth. It's a movement called whisking, and the tactile sensory system also help in exploration, navigation, feeding behavior, and social behavior. But do birds have a counterpart, and would it be the Richter bristles? So the Richter bristles is a type of facial feather that is present in many species of birds, and they're present on the upper beak, and they look like, superficially at least, mammalian whiskers. They also vary in form, in terms of thickness, length, and branching according to species. Despite being present in several species of birds, their function is still relatively unknown. It has been suggested they could protect the eye from item while flying, or increase the mouth gape to catch more food, but they could also have a tactile function. And such function will then help in guiding navigation in dark, complex environments, or aid in prey capture, so like whiskers in mammals. So far, the sense of touch in birds have been mainly studied in the beak tip of birds. They have a tactile sensory specialization called remote touch. So it's a presence of like several tactile sensors in the beak tip. So two of the sensors we saw earlier, herbs and cranberry corpuscles. And those tactile sensors help them discriminate the food item from other items, even in murky water, and so enhance greatly their foraging. The Kiwi is a nocturnal species with a reduced vision, but have highly developed sense of smell, but also possesses remote touch sensing specialization, but it also possesses long Richter bristles. And a study proved that there are tactile sensors all around the follicles of these long Richter bristles. And these tactile sensors are herb corpuscles, is what you see here. So kiwis can harvest tactile information from the ground, not only from their beak tip, but also from their Richter bristles. So what about other species? So we know that Richter bristles are present in many species, but they are really prominent in one of the group called the Caprimulgiform order, which is a niger and their relative, and they comprise putus, frogmouse, the old birds, Olet nigers, nighthawk, and nigers. It's a really interesting group to study with because they are highly diverse among the species, but there is also a lack of knowledge of their ecology, mostly due to their cryptic plumage or their nocturnality. And to try to answer to my question, we had a look at the follicle anatomy of the Richter Bristles, and so we looked at the variation of the skin structure and composition in tissue density and intrinsic fibers, such as muscle and collagen fibers, and the number of the follicles, but more importantly, the tactile sensors presence or absence, position of the follicle, and the number. And so I did some histology work, so we sectioned the skin of the upper beak of several species of the Caprimulgiform order, then stain it with Masson strichrome. We stain in red muscle fibers, and in blue other components like hair corpuscles and collagen fibers, as you can see on the picture. To do so we had the look at the oilbird, which is a nocturnal cave dweller frugivorous bird that echolocate, but he has long Richter bristles that curves down, so make them really interesting. And so the histology work showed a dense tissue with a lot of tactile sensors all around the follicles and muscle fibers underlying the row of follicles. But the common nighthawk, which is a crepuscular insectivorous bird that forages high altitudes in open fields, which had feather-like Richter bristles, so very soft branch and short bristles on the upper beak, had a tissue that was more porous, with no tactile sensors and a few muscle fibers connecting the follicles together. Then you had hairs. So you have here 3 different species of niger, so the pennon-wing, the European, and then fairy-neck niger, which have different ecology and different way of foraging, but they also have different anatomy, follicle anatomy. So the crepuscular bird, the pennon-wing niger, had no tactile sensors here, but had a few muscle fibers connecting the follicles together, while the nocturnal niger had tactile sensors all around the follicles here and collagen fibers connecting the follicle together. And the European niger, which is both crepuscular and nocturnal, so a bit of intermediary, had also an intermediary anatomy with a few tactile sensors at the base of the follicle and muscle fibers connecting the follicles together. So it seemed that there is an interesting association between vision and touch. And so we know that avian feeding ecology often depends upon a trade-off between touch and vision. And some birds will rely more on vision, like eagles, and some birds will rely more on tactile information to catch food, like the birds we saw earlier that use remote touch. And so the part of the avian brain that receive both information, tactile and visual, is the rostral, which is a bump at the frontal region of the avian brain, so you can see here. So the rostral parts receive the somatosensory information, while the caudal part receive the primary visual information. And so I had the opportunity to have a look at the new anatomy. So the roost of the 2 species of nigers, the pennon-wing that were crepuscular with no tactile sensors, and the fairy-neck niger that were nocturnal with tactile sensors. And so that crepuscular bird had larger roost but a larger caudal part, so visual part, while the fairy-neck, which nocturnal, had a smaller roost but relatively larger rostral part, so somatosensory area. So it seemed that crepuscular bird have a tendency to rely more on visual information than a nocturnal bird that will rely more on tactile information. like the Richter Bristles. And furthermore, we had a look at the banal that we know rely heavily on vision, but also nocturnal. And so the banal have very few numbers of Richter Bristles on the upper beak, but they were white, soft, and relatively short and thin. So what you can see here is actually not the Richter Bristles, it's an owl one. And so the anatomy showed no tactile sensors around the follicles or at the follicles, and a few muscle fibers connecting the top of the follicles together. So again, very different anatomy, and it seemed that there is no tactile sensors when the bird have a tendency to rely on visual information. So in conclusion, we confirm there is a high diversity among the species, and there is a variation in time activity, Richter bristle morphology, and Richter bristle anatomy within the species, and it seems that this variation affects how the bird is going to rely on this sensory system. Therefore, Richter bristles may well be tactile and associated with nocturnal foraging. I would like to thank all these people, and thank you all for listening.